Today, the topic of discussion is on refrigeration and air conditioning, that is Module 1, Part 1, PEME 601B. Myself, Dr. Suman Das, HOD, Department of Mechanical Engineering, Swami Vivekananda Institute of Science and Technology. Now, introduction. Concept of refrigeration and air conditioning. Unit of refrigeration, refrigerant, desirable properties, and nomenclature. So in this chapter, in this module, we will discuss this. The process of producing cold by artificial means may be called refrigeration. Now, the term refrigeration may be defined as the artificial withdrawal of heat, producing in a sustainable or within a space a temperature lower than that which would exist under the natural influence of surrounding. That means refrigeration is a process which maintains the temperature lower than the temperature of surrounding. In other words, the refrigeration means a continued extraction of heat from a body whose temperature is already below the temperature of surrounding. Heat is virtually being pumped from a lower temperature to a higher temperature. That means it is going from the lower temperature and throw into the higher temperature. According to the second law of thermodynamics, the extraction of heat from a body at lower temperature to a higher temperature can only be performed with the aid of some external device. Such a device is called refrigerator. So, refrigerator is a device which maintain the temperature the lower than the temperature of surrounding. Refrigerator is a reversed heat engine or a heat pump which extract heat from a cold body and deliver it to a hot body. So that is acting as a reversed heat engine. In the case of heat engine, it is going from higher temperature to lower temperature, and the device which convert heat to work, that device is called heat engine. And refrigerator and heat pump, that is the reversed of heat engine. The substance or medium which works in a heat pump to extract heat from the cold body and deliver to a hot body is called refrigerant. Now, method of refrigeration. So there are two methods. One is vapor compression refrigeration system and another one is vapor absorption refrigeration system. So vapor compression refrigeration system is called VCRS, that is the short form. Vapor absorption refrigeration system, that is VARS. So this is the flow diagram of vapor compression refrigeration system. So there are four basic devices. One is compressor, another one is the condenser. So this is the compressor and this is the condenser. After that, this is the expansion valve or throttle valve through, that is the liquid dryer. It is going into the expansion valve or throttle valve. After that, it is the evaporator, and finally again it is entering into the compressor. Now I am elaborately describe the vapor compression refrigeration system with the help of the flow diagram. So these are the basic component. First one is the compressor. So compressor. So in this case there are four colors. One is the hot refrigerant vapor, that is in the red color. So these zones, when refrigerant is coming out from the compressor and entering into the condenser, the state of that refrigerant is the hot refrigerant in term form of vapor. And when it is entering into the condenser and going out from the condenser, that state is subcooled liquid. It releasing heat and converted into liquid. So that refrigerant through this pipeline and through this dryer entering into this expansion valve or throttle valve. So what is the function of expansion valve or throttle valve? Which is suddenly reduce the pressure and the suddenly drop the pressure and as well as temperature. So due to that, the refrigerant, it is in the boiling refrigerant in the form of liquid, that is suddenly converted into the liquid, and its pressure and as well as temperature both fall suddenly, and that very low temperature, low pressure refrigerant in the form of liquid entering into the evaporator. So evaporator, it is the space, and where we store our food, we store, and from that low temperature refrigerant absorb heat and that is converted into this, that is the cold refrigerant in the form of vapor. So when it is coming out from that evaporator space, that is in the form of vapor, and its temperature is slightly higher, and it is again entering into the compressor for further compression. So this is the cyclic process. So compressor, after that condenser, after that through dryer it is entering into expansion valve or throttle valve, and finally it is going into the evaporator. And again when it is releasing from the evaporator, entering into the compressor for further compression. Now the basic component of vapor compression refrigeration system already I have mentioned, that is, one is the compressor, second one is the condenser, third one is the expansion valve or throttle valve, and fourth one is the evaporator. Now the compressor, so this is the diagram of the compressor. You see the, so this is the rotary compressor. The compressor looks like this, and this is the condenser. That is the backside of the refrigerator. That is the condenser, and this is the condenser. If you see the condenser, this is the condenser. That is condenser in the net in type. So um, similarly, the expansion valve is looks like this. This is the expansion valve or throttle valve, and this is the evaporator. So evaporator is a space where we store our food. So this is the inside of the evaporator. Okay. Now this is the vapor compression refrigeration plant flow diagram. So there are two things. One is the high pressure end, another one is the low pressure end. So the high pressure end, that is the condenser, is in the high pressure end, and the low pressure end, that the expansion valve, evaporator, and the compressor. So this is the cyclic process. So here P1, that is the higher pressure, and P2, that is P2 is the higher pressure and P1 is the lower pressure. So when refrigerant entering into the compressor, that is in the form of vapor, very low temperature form of vapor. So after compression, that is entering into the condenser. So that pressure is very high, and as well as its temperature, it releasing heat. That is Q1 is the heat, it release heat, and again entering in, after releasing heat, it is entering into the expansion valve on throttle valve. So due to the sudden expansion of that, so its temperature and as well as pressure falls down, drop down, and that low temperature, low pressure refrigerant through the, when it's coming out from the expansion valve, again entering into the evaporator. So evaporator where we store our food, so that absorb heat from that space, from that food, and convert it into the vapor, and that is again entering into the compressor for further compression. So this is the cyclic process. It is the vapor compression refrigeration plant flow diagram. So this is the property diagram. So here the PV, TS and HS, these are the properties. So PV is the pressure volume, TS is the temperature entropy, and HS is the enthalpy entropy. So if we consider that when the refrigerant is when entering into the compressor, that is in the saturated vapor, so that is state point 1. After compression, it is entering into the superheated zone, that is state point 2, and 2 to 3, that is condenser part, that is releasing heat and is converted into the part, this saturated liquid. Just just change its phase from 2 to 3. That means state point 3 is the saturated liquid, state point 2 is the saturated superheated vapor, and 3 to 4, that is the expansion or throttling process. That is the throttling process, 3 to 4. So there is a sudden drop of pressure and as well as sudden drop of temperature. So here in the throttling process the enthalpy is constant, and 4 to 1, that is the constant pressure, that is the absorption of heat, and it is that is the uh, evaporator part. So this is the similarly TS diagram. We can also describe the same thing, temperature and entropy. So 1 to 2, that is 1 to 2 is the adiabatic process, uh, reversible adiabatic process, that is here the entropy is constant. 2 to 3, it is the constant pressure process, and 3 to 4 the enthalpy constant, and 4 to 1 this is the constant pressure heat addition. So this is the enthalpy entropy chart, that is the proper. So PV, TS and HS, these are the property diagram of vapor compression refrigeration cycle. Now the unit of refrigeration, that is a very much important unit of refrigeration. So the capacity of refrigeration unit is given by the ton of refrigeration. Okay. So what is ton? A ton of refrigeration is defined as the quantity of heat to be removed in order to form 1 ton of ice in 24 hours when the initial temperature of water is 0 degree centigrade. That means in 24 hours 1 ton of ice 1 ton of water is converted into 1 ton of ice in 24 hours. That means how much heat is to be extracted from that water. That device, that capacity of the device is called 1 ton. So 1 ton of refrigeration, that is 1 ton TR, equals to 211 kilojoule per minute or 3.517 kilowatt. Taking the latent heat of freezing of water is equal to 336 kilojoule per kg. Now we can write easily from this the 1 ton of refrigeration. So 1 ton means the 1000 kg, 336, that is the latent heat of fusion of ice, and in 24 hours. So that will be converted to 14,000 kilojoule per hour, that is 3.8889 kilowatt. So 1 ton is equivalent to either 14,000 kilojoule per hour or 3.8889 kilowatt. Next one is the coefficient of performance. What is coefficient of performance? The COP, or coefficient of performance of a refrigeration system, is the ratio of the heat removed, cooling effect produced. Heat removed means the cooling effect produced from a system to the work supplied to achieve the heat removal. So COP we can easily write that Cp equals to heat removed per unit time, that is the Q, or work supplied per unit time, that is the W. So Q by W. Q is in the form of kilojoule per second, and work, that is also kilojoule per second. So COP is the unitless. So 211 ton, that is kilojoule per minute, divided by 60 P, and so that is finally this. So Tn is the capacity of the plant. So similarly, the relative COP, that is the actual COP by theoretical COP. Now what is refrigerant? Actually the refrigerant is nothing but the working fluid. So refrigerant may be defined as the substance which absorbs heat through expansion or vaporization and losses it through condensation in a refrigeration system. So refrigerant, we can nothing but we can say that it is the working fluid. Now the classification of refrigeration. How to classify a refrigerant? So number one, that is the primary refrigerant. So under this primary refrigerant, these are, that is the NH3, CO2, CH3, Cl2, CH3, Cl2, SO2, C2H5, Cl2, and freon group. These are under the category of primary refrigerant. So they take part directly in the refrigeration and cool the substance on absorption of their latent heat. Next one is the secondary refrigerant. So they are first cooled with the help of primary refrigerant. So secondary refrigerant, they are first cooled with the primary refrigerant, help of primary refrigerant, and then used for cooling other substances by absorption of their sensible heat only, that is ice, solid carbon dioxide. Now that primary refrigerant may be grouped into halo uh, uh, carbon component, that means the freon, genitron, uh, electron, hmm, electron, irontron. So they are the halogenated hydrocarbon. So these are the carbon tetrachloride, that is symbol is R10, that is CCl4, trichloro monofluoromethane, that is R11, CCl3F3, CCl3F, difluoromethane, that is symbol is R12, CCl2F2, mono um, monobromo trifluoromethane, that is R13, CBrF3. So these are the refrigerant. Now the hydrocarbons. Hydrocarbons, they are hydrocarbons, that means methane, ethane, propane. These are also treated as refrigerant. It is the hydrocarbon. Now unsaturated organic compound. They contain ethane or propane as many constituent, that is the ethine, that is R1150, that is propine, the trichloromethane. So these are this category. Now, what are the desirable properties of the refrigerant? So desirable properties, that means which are required, okay, which are desired. A good refrigerant should have the following desirable properties. That is the thermodynamic properties. So the refrigerant should be low boiling point, low freezing point, high saturation temperature, high latent heat of vaporization, high critical pressure and temperature. Chemical properties. So chemical properties, the refrigerant should be non-toxic. So very, very important. So non-flammable, non-explosive, non-corrosive, chemically stable and odorless. So these are the desirable properties of the refrigerant. Now physical properties, that is the low specific volume, high thermal conductivity, high electrical insulation, low specific heat, miscibility with the lubricating oil. Other properties, that may be ease of leakage detection, ease of handling, high COP, ease of availability, and the low cost, low power consumption per ton of refrigeration. So these are the desirable properties in the refrigeration process. Okay, thank you very much.